So good day to our professor. We are the futuristic data analysts. So for today, we are going to discuss the predictive modeling using binary classification for our data, which is all about attrition. Employee attrition poses significant challenges, particularly when experienced and skilled staff leave unexpectedly. This can result in increased costs related to recruitment, training, and productivity loss. Identifying the factors that contribute to attrition allow organizations to intervene early, reducing turnover rates and improving employee satisfaction. The primary goal of this project is to predict employee attrition using binary classification approach. Attrition or employee turnover is a critical issue for organizations as it impacts productivity, morale, and recruitment by cost. By leveraging predictive models, organizations can identify which employees are at a higher risk of leaving and implement proactive measures to improve retention. Our dataset consists of employee information from various departments and roles within a company. So the features include years at company, it's the length of employment, job satisfaction, the self-reported job satisfaction level, monthly income, it's the employee salary, environment satisfaction, it's the satisfaction with the work environment, work-life balance, it's the employee rating of their work-life balance, and the target variable is attrition, which is binary, yes or no. The goal is to build a model that predicts whether an employee will leave the company based on these factors.
Good day, I'm Cecil Do Castro. Before we proceed, here are the following steps to prepare the dataset for correlation. The dataset containing 1,470 rows and 13 columns focuses on employee attrition, aiming to determine factors that contribute to employee leaving an organization. As you can see, the data shows the key variables. The attrition attributes serve as a binary indicator of whether an employee has left the company. This dataset is well suited for predictive modeling using binary classification techniques to identify significant predictors of attrition. Further analysis, such as visualization and correlation studies, can help uncover patterns and trends influencing employee attritions and turnover. The dataset has been divided into a training set, Y-train, with 1,102 rows, 75% of the data, and a test set, X-test, with 368 rows, 25% of the data, for binary classification analysis of employee attrition. The training set is used to develop the model by identifying patterns related to whether an employee leaves the company or stays. The test set evaluates the model's predictive accuracy on new unseen data. The dataset provides an overview of various employee attributes, highlighting a moderately satisfied workforce with average job and environment satisfaction scores of 2.72 on a 1 to 4 scale. Employees are typically 36 years old, have a monthly income of $6,500, ranging widely from $1,009 to $19,999, and an average tenure of 7 years at the company. Most employees have worked at about 2.7 companies with a generally moderate perception of work-life balance. Overall, the data suggests a diverse workforce with varying education levels, commute distances, and employment histories, but moderate satisfaction and stability in their current roles. This data is used in predictive modeling with binary classification likely to predict employee attrition, whether an employee will leave or stay, based on factors such as job satisfaction, income, and work-life balance.
So now let's proceed to modeling. After testing all the model, the first step you need to do is to get the best model based on model's accuracy using accuracy score, F1, precision and recall, confusion matrix, and ROC. Next is to build a model in Python. Binary classification is a supervised learning algorithm that categorizes new observation into one of two classes. After checking on accuracy measures using accuracy score, F1, precision, recall, and confusion matrix, and making prediction to identify which model between naive Bayes, decision tree, logistic regression, and support vector machine or SVM can be best used for the dataset. Based on the accuracy result of our dataset, logistic regression get the highest score, but we decide to use the decision tree classifier and confusion matrix. Decision tree is a tree-like structure. It is easy to understand and visualize because they work by splitting the data based on the most important features. And the confusion matrix visualize and summarize the performance of a classification algorithm. It is a means of displaying the number of accurate and inaccurate instances based on the model's predictions. Its table shows true positive, true negative, false positive, and false negatives. This image is a screenshot of Python code used for preparing data for a machine learning model. In this model, we will see the data display of a predictor variable x and the target variable y. On the left side, it is a video of the predictor variables data frame, which includes 5 columns and 1,470 rows. Each rows represent an employee. The code selects the predictor variables from the dataset, and those are years at company, job satisfaction, environment satisfaction, monthly income, and work-life balance. While on the right side, it is the target variables, which the model aims to predict is attrition. It representing whether an employee has left the company with binary value of 1 or stay with binary value of 0. It is a binary classification problem where the model will predict whether an employee is likely to leave based on the predictor variables. Overall, this setup prepares the data for binary classification. The model will use the features years at company, job satisfaction, environment satisfaction, monthly income, and work-life balance to predict the target attrition and help decide which employees are likely to leave the company.
So in this part, logistic regression was used as our model and various metrics were input to evaluate the performance of logistic regression. These metrics include accuracy, precision, recall, and F1 score. Accuracy and precision obtained 0.842391, while recall has a perfect score of 1. And F1 score got 0.914454. Beside accuracy measure score is the model accuracy results displaying the accuracy scores of logistic regression, support vector machine, naive Bayes, and decision tree. The logistic regression model has the highest accuracy, meaning it correctly predicted the attrition of employees in 84.24%, followed by support vector machine and naive Bayes models that has an accuracy score of both 83.97, and lastly, the decision tree model that has the lowest accuracy among the models with only 74.18% score. Next, this decision tree is a visual representation of how the model makes decisions based on attributes years at the company, job satisfaction, environment satisfaction, monthly income, and work-life balance to predict whether an employee will leave or stay at the company. Each path from the top node to a leaf node is essentially a series of decisions based on employee attributes. The color intensity represents the purity of the node. A fully dark blue node means that the tree is very certain that employees in that node will not live in the company.
So, hi everyone, this is Jan Andre Lama, and I'm the one to discuss our evaluation. So, this is the evaluation of models to predict the employee retention using the confusion matrix. So, of course, confusion matrix help us to deeply understand how well the model performing. So, let's start with the true and negative. So, these are instances when the model correctly predicted that the employee will stay in the company. So there were 4 employees who were accurately identified as not leaving the company. Next, we have here the true positive. So this represents employees who were correctly identified or who were correctly predicted that they are leaving the company. So starting 305 employees who were identified as likely to leave, and they actually do. So next is the false negative. So false negatives occurs when the models predicts that the employee will stay, but in reality they leave the company. So we had 5 cases where employees will incorrectly identified as staying with the company, but actually they leave the company. So lastly is false positive. So false positive are when the model predicts that the employee will leave the company, but actually they stay. So that there were 54 instances where the employees were wrongly or incorrectly predicted to leave the company, but actually they stayed up in the company. So by understanding these 4 categories, we can better evaluate the model's performance and determine where the improvement can be made so that it can reduce errors to predicting employee behavior.
So based on the evaluation of our predictive model, several key factors influencing employee attrition have been identified. To mitigate risk and enhance employee attrition, we propose targeted strategies focused on improving job satisfaction, work-life balance, and competitive compensation. So for job satisfaction, a known driver of attrition is dissatisfaction with job roles or work environment. We recommend conducting employee surveys to better understand specific dissatisfaction points and take action on improving the work environment. Next is for the work-life balance. Employees often leave due to poor work-life balance. Encouraging flexible work arrangements and managing workloads effectively, it could reduce attrition rates. And lastly is for the compensation and benefits. Ensure that employees feel fairly compensated by conducting regular salary benchmarking and offering competitive benefits packages. And that is all for our presentation. Thank you for listening.